So welcome from a lovely Caribbean island. Actually, I'm in Sydney and it's during the lockdown, so this is just me dreaming. But I was looking at the news and I watch the news every day and I see the numbers of cases of COVID in Sydney increasing and in New South Wales more broadly. And it occurred to me that, we could do some modelling ourselves. We don't need the Doherty Institute or anyone else to tell us what exactly is happening. So I thought, let's have a look at some of the data and see whether we can model it and answer some questions like, at the current rate of growth, how many cases will there be by the end of the month, for example, or how many cases by Christmas? What does the current rate of growth indicate? So I'm going to share my screen and we're going to just start from scratch. So let me share this screen here. All right. So hopefully you can see this screen. I'm going to just bring up a new web page and do a bit of a search, see what data we can garner. So I'm just going to search for, you can see I've already done some New South Wales COVID numbers. And this is just a Google search and various numbers that come up, but I'm really interested in being able to download some of this data. So let's have a look and see what's available. We probably need to just type in data download. New South Wales COVID data. See what that brings up. Okay, so let's open up this window and open up that one as well. So if I go to this one first, this is a site called covid19data.com.au. It takes a little bit of a while to load, but it's got all kinds of quite interesting graphs that once they do load, it shows you, how many cases there've been in the last 24 hours and so on. And it also shows you various things like the R number, which might be of interest. But let's just have a look at last 28 days. Let's have a look and see active cases. All right. So we can see that the active cases, there's a line here showing a graph of these cases increasing. If we look at New South Wales, for example, we can actually hover over these things, 7,948 active cases today. Yesterday, 7,463. The day before that, 7,011. And one way I can model this, I can literally just open up a GeoGebra window. Now, GeoGebra is freely available. This is GeoGebra Classic 5, which is freely downloadable from geogebra.org. And I can view a spreadsheet window. I'm actually just going to shut the other windows down for the moment. And in that spreadsheet window, I can just type in some of this data. So if I just make it visible, I can type in maybe the last 10 days. So here's 1, 2, 3, 4, 5. Actually, I'll just do the last 5 days. 6,176. Let me just type these in. 6,176. If you want to see this, you just have to make it a bit more visible. And then 6,567. I can read these off. 7,011. You probably can't see this because it's a little bit small, but if you open it up on your screen, you can. 7,463. 7,948. Okay, so those are the last 5 days. And let's see what we can actually model with this data here. So if I go to this window here and click on the little red arrow, it enables us to do a regression analysis. We've actually only got one variable. So we probably need to just put in another column. So if I just copy that and paste it in here, and then instead of that, I'm actually just going to have a little x-axis. So we'll just say that this is day 1, day 2, day 3, day 4, day 5. And that will give us basically a graph. If I use 2 variable regression analysis and analyze, it brings up a new window which you can't really see, but I can bring this over. Maybe that's the best way of looking at it. Looks pretty much like a straight line because I'm actually just looking at this little section here, so you're not seeing the rest of it. But because I know that that's a curve, I can use a different regression model. I could use a linear regression model. You can see it's not that accurate because it's actually not taking into account the curve, so that these 2 values are over and these values are under. But to get an idea of how good that is fitting the data, I can look at the statistics. There's an R² value of 0.998, so it's actually not a bad representation of the data. And if you look at that formula, y equals 444x plus 5,701, I could then actually just type in my x value. So in maybe at the end of the month, we're almost at the end of the month. Let's just say in 30 days from the beginning of this data. So this was day 1. So by day 30, what would the y value be? And it's telling us that by day 30, using this current model, we would have 19,000 cases. Now, by Christmas, it's currently the 18th of August. So I'm going to guesstimate that we've got September, October, November, December. That's about 4 months. 4 months, 30 days, so about 120. So let's call it 130 days till Christmas, which is roughly right. So 130 days till Christmas. So using this model by Christmas, there'd be 63,000 cases. Now, in reality, you can see if I took more data, it's not a straight line. So let's have a look at, say, a polynomial approximation, which will give you a nice curve. And you can see actually the R² value for this particular case, 5 points, is 0.9999. So it's a pretty good approximation. And you can see that if we use this model after 130 days, there'll be about over 250,000, 289,000 cases by Christmas at the current rate of growth. If you want to see by, in 30 days' time at the current rate of growth, we're talking 30,000 cases. Now, this is just looking at, the active cases. So that might not be a very good measure because obviously as people recover, the number of active cases, doesn't reflect the number of people infected. But we'll keep going for this for the moment because it's nice and easy. We can use something called exponential growth, which you've probably heard of. And this is also 0.9999 in terms of the R² value. Now, this exponential growth is actually what's happening. It's called a geometric progression. And if you want to know what the multiplying factor is day on day on day, you can sort of see it in this e to the power 0.06 times x value. So on your calculator, if you actually looked at, I'm going to have to move this because it's in the way of my other screen. So if I actually type in e to the power 0.06, it tells me that number is actually 1.06. So that's the multiplying factor. Each day, the number of cases, the number of active cases, if you take, 6,567 multiplied by 1.06. So if I store this value in memory A, and I'll take that value, starting value, what was it? 6,176. 6,176 times, you know what I'll do, actually? I'm just going to delete that. I'm just going to put equals. It seems a bit weird, but now I can actually just say answer times A. And we've already stored the value of 1.06 in A. And it tells me that the second day using this model, it should be 6,567 and 57. And it's pretty much bang on. And then the next day, that's not what I wanted to do. I wanted to just press equals. Let's get the previous thing up. Okay. Now if I press equals, there we go. So the next day it should be 6,900. Well, it's actually 7,011. So it's out by about 50 or so. Press equals. Then the next day should be 7,394. Again, it's out by about 70. And then the next day, 7,851. And if I keep pressing equals, 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 so tomorrow, our prediction is it should be 8,300. Tomorrow's Thursday, so by Friday, Saturday, Sunday, by next Monday, at the current rate of growth, there should be about 10,600 active cases. And you can see how this exponential growth, day on day, really starts ramping up. And that's why by Christmas, it reckons if you had the same rate of growth, we would have 21.5 million cases active by Christmas. Well, clearly there's a bit of a problem with that because the population of Australia is only 25 million, I believe. So obviously this model is going to break down at some point. Nevertheless, that's exponential growth. If you want to see this, this is exactly the same thing, this growth model. And you can now see that it's actually got that 1.07 rounded up. I can't quite remember if we look at what A was. 1.06, okay. So it's maybe a slightly different model, but it's a similar kind of exponential growth. You can see that because it's something to the power x. So 1.07 to the power 2 would give you 2 days, and 1.07 to the power 3 and 4 and 5 would give you the increased multiplier of whatever you started with. Excellent. So that's one way we can model this growth. Another way we could proceed would be to actually download the data. So one of these sites, I think it was the first one that I went to, this New South Wales COVID data site. You can see there are various data sets. So if I click on that, we've got various data sets which you can download. I'm going to click on this one here, which is the number of cases in New South Wales by location and likely source of infection. So if we scroll down, we can see that the data is downloadable as a CSV file. I haven't actually downloaded this data before. So here it is. If I just download it to somewhere, my desktop maybe. There we go. And then I can open it up and see what kind of data is available. Let's see what's this is going to give us. Wait for Excel to load. And here it is. Now, I might make this a little bit bigger so that you can actually see what's going on. Okay. First thing I'll do, if I click on this top right corner and then double click, you can then see the data. The second thing I'm going to do is I'm going to actually go to View, Freeze, Top Row. And that means I can scroll down and you can still see what the data is showing you. All right. So we've got the notification date, postcode, all kinds of information about the LGA and so on, and the likely source of infection. I'm not really that bothered about the location, but possibly the postcode, but certainly notification date and likely source of infection. So what I'm going to do is I'm going to highlight columns A to C. And then I'm going to insert something called a pivot table, which is this top left one. Insert pivot table. And I'm going to just add it to a new worksheet. I don't know that I can't add that to the data model, so I'm just going to see what that gives me. What it will enable me to do is I can drag notification date into rows. Okay, which is giving me years, and quarters and notification date. So let's just expand this and see what we get. Okay, we get, it's giving it to me by quarter, which is not quite what I wanted. January, February, March. Okay. I'm really interested in the days. Okay, it's not giving me that. And okay, it's actually, let's get rid of the quarters and years. Not quite sure how to adjust this. Field settings. Okay. I was hoping this would actually just give me the date. Likely source of infection. Okay, let's put that underneath and see what that does. It's a bit better. Maybe if I swap those around, what does that give me? Interstate, I'm not really interested in. Locally acquired, yep. Overseas, I'm not really interested in. So let's just see what we can do here. We can filter and we can just go locally acquired, links to known cases, investigation ongoing, and no links to known cases. I want to basically see all of the locally acquired cases. Now let's just get rid of notification date, or maybe put it in values and see what options we've got here. Yeah, that's not really what I want. Columns, maybe. Yeah, okay. See what happens there. So if we just move that into here, we then get a count. Now that's not really very interesting because I'm not interested in how many cases in August. I'm more interested in how many cases per day. So I'm not quite sure. Doesn't seem that we can do that. Let's go back to the original data. Notification date. Okay, I've got it. Got an idea here. So what we're going to do is we're going to put in insert. And I'm actually interested in maybe from the beginning of August, modeling from, oh no, let's say the beginning of July, So I'm going to put here days after the 1st of July. And what I'll do is I'll do a little formula equals whatever this day is, take away the 1st of July. Okay, so that tells me to work out the number of days from this day, which is actually the 25th of January 2020, take away the 1st of July. So this will give us the negative result. I also don't want it to be a date. I want it to be a number. Okay, and that's given me a positive result. So something's clearly wrong with that formula. Let me just have a quick look down and see what I'm going to get. Right, okay, so it's not, okay, I've got it. What I actually need to do is tell it that this thing here is a date. So let's try that. Date, year, month, day. Okay, so year 2021, month September, July, day 1. And that's more like it. That's much more like it. Okay, now I actually don't want any of the data before the 1st of July. So what I'm going to do is I'm going to highlight that whole thing. I'm going to do a data sort. I'm going to sort by column B, smallest to largest. And then I'm simply going to go from here and scroll down all the way down. In fact, I don't need to bore you with this. I can just use the slider until I get to the 1st of July. Ooh, let's go back. Okay, so 1st of July is here. And I'm just going to press the Shift key and then hit that, right click, delete. Excellent. So now I've got all the data after the 1st of July. And I'm not really interested in the date anymore. I'm just interested in the number of days after the 1st of July. I'm also interested in the likely source of infection. But actually, I'm not that bothered about the different sources. All I want to know the locally acquired sources. So you know what? I'm going to actually do a bit of data wrangling here, insert a column here, and I'm just going to put locally acquired, if I can spell it. And I'm just interested to know if this here starts with the word locally. And I'm going to use a formula for that. So before I do the full formula, let's show you how to work that out. So I can use something called left, which just returns the first few characters of a particular field. So it's telling me it wants the text. So I want the left part of whatever's in this cell here. And I just want to look for the word locally. 1, 2, 3, 4, 5, 6, 7 letters. So I'm just put 7 letters. And it says locally. Okay. So if I copy that down, the quickest way to do that is to double click on this little square. Obviously, it's taking the first 7 letters of this, which is overseas. So as long as it says locally, I'm interested in. If it says anything else, I'm not that interested. So I'm actually going to add to this formula, and I'm going to say if the result of that is equal to locally, then I want it to put a 1. Otherwise, I want it to put a 0. Copy it down, and there we go. So now I can filter out all the zeros or all the ones. The easiest way to do that, if I want to just make sure that I'm getting them all, I'm going to sort it again. So highlight the whole thing, sort by column C, which is locally acquired. If I do smallest to largest, I'm going to get the overseas cases first. So again, I can highlight that and then just scroll down until I get to the ones, which are the locally acquired cases. Don't have to go very far. Scroll back up again. There we go. So I'm going to just delete the first 109 entries. So again, just right click, delete. Okay, so now I have all the locally acquired cases from the beginning of July going down to the last case, which is around, how many cases? See how far down we have to go. Quite a few cases. So there have been a total of 9,000. You've got to take away 1 because the first row is the titles. So there've been 9,076 locally acquired cases of COVID in New South Wales since the beginning of July. Who knew? Excellent. So now what we can do is we can actually just take this data here. I'm actually going to use Control-Shift-Down, which hopefully should just highlight the data that we're interested in to the end of that data. And if I insert a pivot table, I can then click on OK. Here it is. And now I can just put the number of rows. There we go. So this is now the days after the 1st of July. And obviously it's been 47 days since the beginning of July. And it doesn't really matter what I put in here, but basically the sum of locally acquired cases that would do, or I could do the count, value field settings, I could do the count, and that should give me exactly the same result. Okay, so there we go. Now I've got some real data. I can put a graph. So if I highlight all of this, what I'm actually going to do is I'm going to just go down to the end. I'm going to highlight it. I'm going to copy it, and I'll paste it as values. Okay, so paste as values. And the reason for that is because this is a pivot table and things, the data can change in the pivot table. I can actually now take those values and I can actually paste it directly into GeoGebra if I want. So rather than this graph, I'm going to actually get rid of that data analysis window. I'm just going to paste it here. Here we go. Wow. Now I've got a lot more data to deal with, so I can go right down to the end here. And if I want to, I can do the same analysis, a regression analysis, analyze that. Wow, look at that. That's a bit better. Now you can see my regression model at the moment is a growth model. It's reasonable R squared, 0.91. The R squared value can go up to 1, which would be perfect fit. The exponential model gives me an R squared value exactly the same. It's basically the same model. Polynomial model, you can see that the quadratic model is actually a better fit to the data. But more recently, it hasn't really fitted the data brilliantly. Having said that, you know, it's interesting. I thought there were 600 new cases, but according to this, there are only 455 new cases. Maybe it hasn't included today. Maybe that's just up to yesterday. We can just confirm that. I'll just go back to confirmed cases. 17th, yeah, it's up to yesterday. So we know there were 600 new cases today. So we could add that in, I suppose. If we did, we'd probably see that, well, let's have a look. 48. I actually need to find out exactly how many cases there were today. How many new cases? Last 24 hours. 634. That's with one overseas case, so 633. 633. And I think I'm going to have to redefine the data set. So let me just shut that down. It's not going to take very long. So if I go back, go from here up to the top. Maybe I have to go from the top down to the bottom. There we go. And regression analysis. Analyze. Okay, so you can see that new figure there, 600. So I don't know whether this quadratic is necessarily the best fit. Maybe, well, you can change the power. You can make it into a quartic. If you turn it into cubic, the problem with that is that it sort of wiggles a bit, but it's a better fit. A quartic would be an even better fit, as you can see. But I think I'll go back to a quadratic because, you know, it's not a bad fit. So again, let's now take this and look at how many cases by Christmas according to this. So this is saying that by Christmas we'll be having 3,900 new cases a day according to this model. If we did use a quartic, we'd be talking about 47,000 new cases. And if we're using an exponential model, we're talking about 97,000 new cases per day. You can see the exponential model is exactly the same model as before, e to the power 0.06, which I think we found was about 1.06. Am I right? E to the power 0.06 is about 1.06. And I've realized now the reason why that isn't the same as the growth model exactly is because this is only actually 3 significant figures. It's one decimal, it's one significant figure. It's 2 decimal places. And we could go to options, rounding, and have a few more decimal places. And I think if we did that, nothing's changed. Oh yes, there it is. 0.0617. 0.074. Let's try that. See whether that makes a difference. E to the power 0.06174. Okay, now that might be a little bit closer to the growth model. 1.06368. You can see it's exactly the same model. It's just instead of putting the multiplier or the exponential part, exponential part or the power, instead of putting that as e to the power something, it's just writing it out as 1.06. So that is the same model as that. That's about it. So this model here is showing you, and this data is showing you the number of new cases by the time we get to 130 days. And the previous model I showed you was showing the total number of cases when you add that up. Of course, if you know anything about geometric regressions, you could use the value of R, which is 1.06368. You could use that value of R, and you could actually work out the sum of the first 130 terms. And I think, as we've seen before, that should give you about 21 million, which is the number we got before. So I hope you found that interesting. There's lots of scope for investigations using either Excel or GeoGebra or a combination of the two. If you do want to take this equation and plot it, you can also use the GeoGebra algebra window, not algebra, the graphics window, and you can type in the formula that you got in the graphics window. Unfortunately, I can't see it anymore. Where is it? Ah, there it is. So I can type in the formula 31.75 times 1.06368 to the power of x. And that should give me a graph, which I probably can't see because I need to scroll out a bit. And there it is. Now, if you want to scroll out, but you don't want to scroll out with both axes, you can click on this here, hover over the y-axis, and click and drag. And that allows you to then see what would happen by the time you got to, say, 130. So if I scroll out a bit more, so Christmas is about x equals 130. There it is. You need to scroll out even more because it's an exponential graph. You can really see the growth. And hopefully we should get a value here. If I put a point on the intersection, well, I can just put it on the intersection of this line and this line. And it should be able to find that. And there it is. And that point there, if I look at the algebra window, is telling me the y coordinate is 97,089. I'll just move this over a bit. Oops. Is that the value we got before? Oh, maybe I'll make this a bit longer. You can also pop this out if you prefer. I'll just show you how to do that. If you hover over the next to this close button, you'll see show view in the new window. And that might be a bit easier to manipulate. So 97,127. The reason this isn't quite the same is because the formula I put in 31.75 was an approximation to 31.75124, and so was the exponent. But it gives you another way of showing that. Of course, I suppose what you could do is you could have a slider here. You can put a slider in, make it an integer, 1 to, I don't know, 130, for sake of argument. And that's called n. And then we could just have a line saying x equals n. With any luck, as I move that, you'll see that moves the line. And then we can have a point on the intersection of this line and this line, point B. And we can even display the y coordinate of B. I think it's under this one here, text. Let's put some text in here. So number of cases equals the y coordinate of B. Now, I'm not sure whether I can do that here. I probably need to, let me just click on OK here. I probably need to define something as the y coordinate of B. So let's call it, I don't know, h equals the y coordinate of B. There we go. And you can see that figure here. And then I can just say number of cases. Oh, let's just edit this. Object properties. Maybe I just need to double click on this actually. Let's try that. Number of cases equals. No. Okay, you know what I'm going to do? I'm going to start again. I'm going to just start again. I'm going to get rid of that. Delete. Start again. Number of cases. I'm sure there's a way of editing it, but I can't remember how. Equals. You can either just click on this here, H, and you'll see it comes up as a H with a box in it, or you can actually just go to Objects and then scroll down to H, which is here. I'm not going to bother with that because I've already got it. And there's the preview LaTeX formula if you want to make it sort of squiggly, but I'm not that bothered. You can also round it, but I can't remember how to do that, so I'm not going to bother. There we go, number of cases. And you can make it a bit bigger maybe. I can now get rid of the algebra window. I don't really need the spreadsheet window showing. I can highlight that and change this so that it's large, maybe change the color of it if you like. There we go. And now I can have a look and see the number of cases as I increase the number of days towards Christmas. Now let's hope this doesn't happen, folks, but this is exponential modeling. There we go. Hope that gives you a few ideas. Good night.